This is the third topic, which is about bonding and structure. In this topic, you will study about different types of bonding. You took three types in O levels: ionic, covalent, and metallic. But there's another type which you will also study in this chapter, that is dative covalent or dative bonding. And in detail, you will learn about the structure of ionic compounds and more information related to ionic substance and ionic compound. So, starting first with ionic bonding. What is ionic bonding? A bond which is formed by a complete transfer of electron from one atom to another. So when there is a complete transfer of electron from one atom to another, this type of a bonding which result in a formation of a positive and negative ion, we call ionic bonding. Metals, it is normally occur in between the metal and the non-metal. So metal tend to lose all of its valence electron, and non-metal tend to gain electrons to complete its octet. Octet means eight electrons in the outermost shell. So example, this is the outermost shell. So as the metal will lose electron, the charge which appear on the metal will be positive. As the non-metal gain electron, the charge appear on the non-metal will be negative. And the electrostatic attraction between the ions, there's a positive and the negative ion, and there's an attraction between the ion. This attraction refers to ionic bond. In terms of electronic configuration, how you can explain how ionic bond is formed or what will be the electronic configuration? Example, if you want to show a ionic bond between magnesium and oxygen or ionic bond within magnesium oxide, so how we can represent this? First, we will write the electronic configuration for magnesium. As we know, magnesium is Mg 12 and 24. So if I write electronic configuration for this, it means it is having 12 protons and 12 electrons because overall it is neutral. So 1s2, 2s2, 2p6, 3s2. So in the valence shell or the last shell, there are two electrons. And I told you, metal tend to lose all their valence shell electrons, so that inner shell will be more stable or it is complete. When you take oxygen, oxygen is 8 and 16. When we write the electronic configuration, it is 1s2, 2s2, 2p4. So this oxygen inner shell, there are 6 electrons. So it needs 2 more electrons to be stable. From where it will get 2 more electrons? So this magnesium will lose electron and oxygen will gain electron. So what will be the configuration of this magnesium after loss of electron? Because the last shell electron is being removed, so it will be 1s2, 2s2, 2p6. So total number of electron in the second shell, 2 in the s orbital and 6 in the p orbital. So total will be 8, which increase the stability or make it inert or unreactive. Same way, oxygen, it originally it was 1s2, 2s2, 2p4, but it took 2 extra electrons from magnesium. So the valency will be 1s2, 2s2, 2p6. And the charge appear because magnesium lose electrons, so there will be a plus charge. And oxygen gain electrons, so there will be a negative or a minus charge. Then there's an attraction between the positive and the negative ion, and this electrostatic attraction between the ions is refers to ionic bond. Is it clear? Any doubt in this part? Then how this ionic compound exists? You don't have only one magnesium ion and you have one oxygen ion. There are millions of magnesium and oxygen ions. They held together by a strong electrostatic force and arranged in a regular pattern. And this regular pattern is known as lattice. So you can see the ionic crystals have a giant structure of the ions, which we call our lattice. An ionic bond is a strong electrostatic force. There is a strong force between the oppositely charged ions. Positive and negative ions attract each other, so strong electrostatic force is there, which held them together. We call this force as ionic bond. The regular arrangement of the ions, this whole regular arrangement, definite arrangement, what we call that as lattice. And you can see the ionic bonding is stronger and the melting points are higher when the ions are smaller or they have a greater charge. What is the reason why it happened like this? That why the ionic bonding becomes stronger or why the melting point also increases? Because melting point, when you supply the energy, temperature at which the substance changes state, that's a melting point. So when this ionic compound changes the state, the ions should move away from each other. So we have to supply enough energy so that we can move these ions away from each other. And these ions can move. If stronger force of attraction is there, it means we need greater amount of energy to move these ions away from each other. So in case of when we compare magnesium oxide with sodium chloride, so magnesium is having a higher melting point than sodium chloride. What is the reason? When you compare the size, for example, you have sodium, which is 11 and 23. So inside the nucleus, we have 11 protons. I'm not drawing the neutrons here. First shell, we will have 2 electrons. The second shell, we have 8 electrons. And the third shell, there is 1, but if sodium loses electron, because in ionic compound, it is a sodium ion. So when sodium loses electron, it will have 2 shells. So 11 protons are attracting electrons from the second shell. So protons are attracting electrons from the second shell and 11 proton. But when you take magnesium, magnesium is 12 and 24. So it contains 12 protons. First shell, it will have 2 electrons. Second shell, it will have 8, and third shell 2. But if magnesium loses those 2 electrons, so there will be a magnesium ion and it will have 8 electron in the second shell. So as there are 8 electron in the second shell, these electrons are attracted by how many protons? 12 protons. So 12 protons are attracting these outer shell electrons in the second shell. So what happened? In this case, each ion, each electron experience stronger force. So when we compare the size of sodium ion with magnesium ion, even though they have the same shells, 2 shells are occupied, but which one will have a smaller size? We will observe the magnesium will have a smaller size. And what's the reason why there's a smaller size? You can see greater nuclear charge or greater number of protons in the nucleus. So it has a strong electrostatic attraction towards the electron. That's why the size decreases. Now, what is the advantage of this small size? When size is small, the ions are closer to each other. So if there is a compound which is involving a magnesium and oxygen, and there's another compound which involves sodium and oxygen or sodium and chloride. If this is a sodium ion, and then there's oxygen, with a charge of -2. And if there is a magnesium ion, so magnesium ion is smaller in size compared to sodium ion. So ions will be closer. If ions are closer, they have a strong attraction. And if they have a strong attraction, it will be difficult, or we need greater amount of energy to separate these ions or to change the state. That's why the melting point of magnesium oxide will be higher as compared to that of sodium oxide or sodium chloride. Even I can take chloride here. The same reason. Is it clear? Why the melting point of sodium oxide is, or sodium chloride is lower than magnesium oxide. Any doubt in this part? Then what about the ionic radii, or when we compare the size of the ion? So positive ions are smaller as compared to that of atom. What is the reason? Like example, if I compare sodium atom, the size of a sodium atom with sodium ion, so I'll find when I compare the size, sodium atom is greater in size as compared to sodium ion. What is the reason? Because in sodium atom, we have a nucleus of a sodium. First shell 2 electron, second shell 8 electron, third shell 1 electron. This is sodium atom which contain 11 protons in the nucleus. But when I draw a sodium ion, so sodium loses 1 electron. So as it loses the outer shell electron, so that outer shell is no more counted. So only 2 shells are there, and when I draw, 11 protons will be there and 10 electrons. So 10 electron, first shell it will have 2 electrons, and the second shell it will have 8 electrons. So as you can see, when you compare the sodium atom with sodium ion, you can clearly see, because there are less electron shells in positive ion as compared to that of sodium atom. That's why what you will observe, that the size of the ion, positive ion, is smaller as compared to that of atom. But if you compare the ions, negative ions, you will find they are larger in size as compared to corresponding atom. Like if I'm comparing fluorine, which is, when we compare fluorine with fluoride ion, we'll find fluorine atom is having a smaller size as compared to fluoride ion. What is the reason for that? Because when you draw the structure, first shell it will have 2 electrons, the second shell it will have 7 electrons. So there are 9 protons in the nucleus. First shell it will have 2, second shell it will have 7. So there are 7 electrons in the second shell which experience attraction from the 9 proton inside the nucleus. But if it is a fluoride ion means it gain electron. If fluoride ion is there, it shows that it gain electron. So as it gain electron, the outer shell will have more electrons. So each electron experience a smaller force, a weaker force. So as the force reduce or a force decrease, what we will observe, the same second shell, but greater in size. Why it's greater or larger in size? So there are 9 protons. First shell it will have 2 electron. Second shell it will have 8 electron. So each electron experience a weaker force. That's why the same second shell, but it's a bit away from the nucleus. So the atomic size increases. So fluoride ion, when we compare the size of the fluoride ion, it will be larger as compared to fluorine atom. So the negative ions have more electrons than the corresponding atom, but the same number of protons. So the pull of the nucleus is shared over a more electron. That's why making it bigger. Is it clear? The comparison? Any doubt in this part? Now, if we move across the period, what we will observe, like example, if we are comparing the size of nitrogen with nitrogen ion with oxygen and with fluorine, they are called isoelectronic. Why we call them as isoelectronic? Because they have the same number of electrons. Nitrogen atomic number is 7, okay, but it took 3 electrons. Oxygen atomic number 8, fluorine 9, neon is 10, sodium is 11 atomic numbers. Magnesium is 12 and aluminum is 13. Nitrogen took 3 electrons, so how many electrons will be there? 10. Oxygen took 2 electron, 10. Fluorine took 1 electron, 10. This was cannot react, so it will be same 10. Sodium 10 loses 1 electron, magnesium loses 2 electron, aluminum loses 3 electron. If we compare the isoelectronic structures, isoelectronic means they have the same electrons or a same electronic structure or same number of electrons. So what you will find nitrogen is much larger in size as compared to oxygen. Oxygen is bigger than fluorine. What's the reason for that? It's easy to understand the reason when you draw the structure. Like if I draw the structure of nitrogen ion, nitrogen originally, because nitrogen atomic number is 7, so 7 protons are there. And nitrogen is a non-metal. So for a non-metal, it reacts by gaining electrons. So it took 3 electrons. So this is normal nitrogen. First shell, it will have 2 electrons. Second shell, it will have 5 electrons. But what happened? It took 3 extra electrons. So as it took 3 extra electrons, So in 7 protons are attracting the electrons, more electrons in the outermost shell. That's why weaker attraction towards each electron. So as weaker attraction between the nucleus and the outer shell electron, the size will be larger. But why oxygen is smaller? Because oxygen is having a greater charge. You can see when I draw oxygen, oxygen is having 8 protons. And these 8 protons are attracting electrons from the outermost shell. 8 electrons. So comparatively, when you compare the attraction, oxygen will have a greater attraction because greater nuclear charge as compared to that of nitrogen. That's why oxygen size, if attraction is more, size will be smaller. If attraction is weak, size will be bigger or larger. Is it clear, this part? And about sodium, magnesium, and aluminum, because what happened? Metal tend to lose electron. So sodium 10, magnesium, the stronger nuclear charge and less number of electrons. So that's why greater attraction. Look what happened here in case of when you compare nitrogen with oxygen. Nitrogen is having 7 protons. Oxygen is having 8 protons. So if it is having 8 protons are attracting 8 electron in the second shell. 7 protons are attracting 8 electrons in the outermost shell. So each electron will experience weak force. As each electron will experience weak force, so if the force between the nucleus and the outer electron is less, then its size will be larger. Or if so force is more between the nucleus and the outer shell electron, then the size will be smaller, or we can say they are inversely proportional to each other. When you compare sodium with magnesium and aluminum, why you observe the size is decreasing? So sodium ion Sodium ion is having 11 protons and 8 electron in the outer second shell. Magnesium ion Magnesium ion is having 12 protons and 8 electrons in the outermost shell, where aluminum is having 13 protons and 8 electron in the outer or the second shell. So when you compare for sodium, 11 protons are attracting 8 electron in the second shell. When you compare magnesium, 12 protons are attracting 8 electron in the outermost shell. And aluminum, 13 protons, 8 electron in the outermost shell. So which one will experience stronger attraction? When you compare, you can see aluminum stronger attraction than magnesium and magnesium stronger attraction than sodium. That's why when you compare size, I told you if there's a stronger attraction, if force of attraction between the nucleus and outer shell electron is more, then its size will be smaller. So that's a reason in case of aluminum, 13 protons are attracting same number of electron in the second or outer shell. So size of aluminum ion will be smaller when you compare these isoelectronics. Is it clear, this trend? friend, in the ions for isoelectronics, isoelectronic means when we have same number of electrons in the ions, we call them as isoelectronic. So why does so this nitrogen, oxygen, fluorine, sodium, magnesium, aluminum, these all ions have the same number of electrons, but still their sizes are different. Why the sizes are different? Because they have different nuclear charge. And within the group, the size of ionic ray, when we go down the group, the number of shell increase. So what we'll observe, the size will also increase. Is it clear? Yes, Umar, is it clear now? Then there are certain definitions which are related to this ionic lattice. What is enthalpy of the formation? What's the meaning of enthalpy of formation? When elements form a 1 mole of a compound, elements result in a formation of a compound, 1 mole of a compound, at standard condition. What are standard condition? 25 degrees centigrade or 298 Kelvin and 1 atmospheric pressure. When the compound is formed and under these condition, the energy which is released or energy which is absorbed, this energy is known as enthalpy of formation. So you can see here, you have sodium element, you have chlorine molecule, but the condition it should form 1 mole of sodium chloride. So 1 mole of NaCl. So this should be half Cl2 because of balance equation. So whenever 1 mole of a compound is formed from the elements, the energy released or energy absorbed, what we call this energy? We call that as enthalpy change of formation. So this can be like carbon react with oxygen, gives carbon dioxide. So carbon is solid and oxygen is a gas. So carbon react with oxygen, give 1 mole of a carbon dioxide. The energy change, it can be endo, it can be exothermic, but the energy change is also known as enthalpy of formation. So when a compound is formed from its element, the energy change is refers to enthalpy of formation. Same way, if you have H2 plus Cl2 gives 2 HCl. So this is the twice of enthalpy of formation because 2 moles are formed. So if I want to form 1 mole, then what should be the equation? The balance equation for this? If I need 1 mole of HCl, then I should have half mole of hydrogen and I should have half mole of chlorine, so that I'll get 1 mole of HCl, and the energy change for this reaction is also known as enthalpy change of formation. If it is done at a standard condition, then we use this symbol as well. This is if standard condition is used. And what are the standard condition? That temperature is 298 Kelvin or 25 degrees centigrade, 100,000 Pascal or 1 atm, and all reactant product in their standard state. In standard, like hydrogen exists as a gas, chlorine exists as a gas, hydrogen chloride is a gas as well. It can turn into acid when we dissolve in water, but at room temperature, hydrogen chloride is a gas. Is it clear the definition of enthalpy change of formation? You have to learn this definition. Like another example, if so the idea is that whenever elements are forming a compound, 1 mole of a compound, that reaction enthalpy change or energy change is known as enthalpy change of formation. So if you want to form magnesium oxide, so magnesium is reacting with oxygen, gives magnesium oxide, MgO. So how many oxygen should be there? Half, because I need MgO only. Magnesium is a solid, oxygen is a gas at room temperature, and magnesium oxide is also a solid at room temperature. So I get 1 mole of magnesium oxide. The enthalpy change, the energy change which occur in this reaction, whether it's endothermic or exothermic, that enthalpy change is known as enthalpy change of formation. Is it clear, this definition of enthalpy change of formation? If you have any doubt, feel free to ask question during a class. What is definition of enthalpy of atomization? Enthalpy of atomization means when we produce atom from element, element can be any state. If from element we produce atom of that element in a gaseous state, and we should produce one atom. So from element, if I'm able to produce atom in a gaseous state, what I will call? I will call that as enthalpy change of atomization. So example, chlorine is Cl2, which is a gas. If I, from chlorine molecule or element, which is element, if I produce one chlorine atom, also in a gaseous state, the energy change which occur, also known as atomization. And atomization is always endothermic. It cannot be exothermic atom, because to make something atom or to break the bonds in the molecule, you should always supply the energy. So atomization are always endothermic. It can never be exothermic. But this equation is not balanced because I need 1 mole of chlorine atom. So I should have half chlorine molecule. These are theoretical definition. Practically, you cannot have half chlorine molecule, but theoretical definition of atomization means it is energy required to produce one atom of any substance in a gaseous state. And atomization are always endothermic, so energy change for them is always positive. Same way, if I have sodium, sodium is atom in a solid state. I supply energy so that I will convert this sodium atom in a gaseous state. So enthalpy change is also known as atomization of sodium. If I have oxygen, which is O2, but I want to, oxygen is already a gas. So I have oxygen, which is O2 in a gaseous state, but I want to produce one oxygen atom. So how much energy is required to produce one oxygen atom from the molecule? But equation is not balanced, because here we have two oxygen atoms, but right side we need only one. So if I have a half oxygen atom in a gaseous state, half oxygen molecule in a gaseous state, I supply energy to produce one oxygen atom. What I will call that as enthalpy change of atomization. But as you can see, for group 8 elements such as helium, so helium is already a gas and it is also atom. So atomization, we cannot do anything else. So atomization of these noble gases is 0, because already the noble gases are in an atomic state and they all are gases. So atomization of helium, atomization of neon, argon, xenon, krypton, these all gases, their atomization is 0. Why 0? Because they are already atom and they are in the gaseous state. So we don't have to make a molecule. But why for chlorine atomization is not 0? Chlorine itself, it is a gas, but it is not atom. So that's why we have to convert a chlorine gas into chlorine gaseous molecule into chlorine atom. That's why its atomization is not 0. There will be some value. And atomization is always endothermic. But for inert gases, group 8 element, helium, already atom in a gaseous. And if I want to convert into atom and gas, it is already there. So I don't have to convert. That's why atomization is 0. Is it clear? The definition of atomization? Any doubt in this part? Ionization is energy required to remove electron from a neutral gaseous atom we call ionization. If we remove the first electron, like if sodium is there in a gaseous state, and we remove the electron from sodium atom in a gaseous state, if we remove one electron, we call that as first ionization. But if we remove the second electron, sodium ion already there in a gaseous state, we supply more energy so that we remove electron from sodium ion so that it will become so +2 charge. So it become +2 charge by losing one electron. So this is also known as second ionization. So first ionization when we remove the first electron. Second ionization when we remove the second electron. Is it clear? And the second ionization is always higher than the first ionization because here a neutral atom you're removing electron, but already a charge is there and you want to remove electron. So this electron will have attraction towards the positive ion. So it will become difficult to remove electron. That's why the second ionization will be higher than the first ionization. Always it is higher than the first ionization.